Hello friends. Now there is a one topic in electronics, that is Ohm's law. Ohm's law and Kirchhoff's law are used for calculating the current passing through the circuit or calculating the voltage across any element. So now we will start with the Ohm's law. Ohm's law is nothing but the voltage is directly proportional to the current, that is V is directly proportional to the I. So we can say that V divided by I is a constant. So what is that constant is? That is R. R is our resistance. So in the circuit we can say that if the voltage applied in the closed circuit, that is V, with the current I in it, then resistance is R, that is this zigzag line and capital R. So this is an ampere calculating the ammeter. And now there are few types like ohmic conductor. So what is ohmic conductor? The any conductor which follows the Ohm's law, it is ohmic conductor. So in the graphical representation of current and voltage, so we can say that IV graph. So it is a straight line when we put various values in the formula of V divided by I is equal to R. So we will get some constant point, and these constant points are follows a trend of straight line. But some of the conductors which will not follow the ohmic law, and those conductor will show various patterns like this one in the IV graph. So there is not straight line, then we will call it as non-ohmic conductors. For semiconductors, let's take semiconductors IV graph. So what is it showing is voltage is minimum applied, and if voltage is increasing in this direction, let's say, then the current is increasing very fast, rather than when ohmic conductor is showing straight line, which will be like this point in increase. But in this case of semiconductor, we can see that current is increasing rapidly at the very early stage of increasing of voltage, right? So semiconductor if are used in many appliances of our day-to-day life, like our mobile phone. The mobile phone earlier was a simple phone with a very large size. So why it is so? The quality of conductors were used was not that much efficient. So nowadays various research has taken place, and those research are helpful to minimize the size of our appliances. So more efficiently we can take some conductors like semiconductors in the appliances which show high efficiency with low voltage, like this. Okay, so we can say two conditions: I increases non-linearly with voltage, and in this negative direction there is a little current flow. Clear? So now we will consider some terminology for our Kirchhoff's law. What are those? Various terminology are like network elements. So network elements are nothing but the individual components in the network. Okay, so what is network here? Network is the just combination of these individual components. The combination of various components forms the network, and there are two types of network. Let's say passive network and active network. So what is passive network? A network containing circuit elements without source of EMF. That is, we can say no EMF, right? So there is no voltage, right? So we can say that is passive network. In the case of active network, there is a presence of EMF. Okay, so next one is loop or mesh. Loop is nothing but those individual components of which are of which are found in the network are arranged in the closed manner. Okay, so a set of branches forming a closed path in a network is called a loop. Okay, so if we can say this is a resistance, this is a EMF source, and likewise many components can be used in this network, and these are all branches are connected to each other and forming a closed loop. So that is nothing but loop. Next is a constant voltage source. It is denoted by a zigzag line and the ideal voltage source is one whose terminal voltage remains always constant irrespective of amount of current drawn, and it has very low internal impedance as compared with the load resistance. Okay, next one is a constant current source. It is denoted like an arrow in the circle and it is put in the circuit. So an ideal current source is one who can deliver a constant amount of current independent of the resistance. Okay, so we can move to the next point of our topic. So remember, these terminologies are important for the Kirchhoff's law. Now we will move to the Kirchhoff law. Kirchhoff law is of two types. First is Kirchhoff's law of current, that is Kirchhoff's current law, and another for voltage, which will be like Kirchhoff voltage law. So what is Kirchhoff current law? Algebraic sum of the current meeting at a junction of network is 0. So let's consider a junction point where various currents are coming or going away. Here we can say I1 is coming to the junction, I2 is moving away from the junction, I3 is moving to the junction, I4 is also moving to the junction, and I4 is moving away from the junction. So I5 is moving away. So let's say the summation of the all currents at the point of this junction is O. Okay, so summation of I is I1, which is moving to the junction, so we can take a positive. I3, which is moving to the junction, so we will take it as positive. And then I4, which is also moving to the junction, so positive. I2 is moving away from the junction, so we should take it as negative sign here. Again I5 is also moving away, so we will take it as negative sign. So we can write it as like I1 plus I3 plus I4 is equal to I2 plus I5, right? So what Kirchhoff's current law is saying is like all the current summation is 0 at the junction, right? So we will take it as all this current summation is 0 with considering the sign convention, and then we will get this formula. Okay, next is Kirchhoff's voltage law. Kirchhoff voltage law is an algebraic sum of voltages, okay, around and closed path or mesh of a circuit is 0. Okay, so what it is saying is consider a simple network with various components in it. Like in this network is open here at this end and open at this end, but we will consider only this part of the circuit. Okay, so which components are used in this closed path? E1, that is EMF, R1 is a resistor, E2 is a EMF second, R2 is a resistor second, R3 and R4 respectively. So according to the sign is this denotes positive on this side, negative on this side, and R1 is a resistor with a positive on this side and negative on this side. So when the current is flowing in this direction from positive and then coming to the negative, so it is, let's say it is I1, here also I1. In this line you can say the current is flowing I1. Okay, so it may get varied in this position and in this position, right? So next consider this line. Here the sign is, this long straight line is positive, small straight line is negative, so voltage is decreasing. So and current is flowing from this positive side of the EMF, and so we can say the current flowing through this line is I2. Okay, and sign as given is positive, connect to the positive of the resistor and moving away, that is negative on this opposite side. Now again, some of the quantity of I2 may get added with the current flowing this from this direction. So we will say that is I3, not I2, because some current may be added and change in the current, or some current may be decreased. So there are two conditions. So we can say the I3 is different from this current. So current is flowing from this line is I3 and resistance is R3. So sign convention is given like positive, negative. Okay, again in this scenario that is also positive and negative. Current flowing this R4 is I4. Clear? So now we will take it as a closed circuit, and we will actually move through the circuit to consider what is the sign convention for our formula of the Kirchhoff's voltage law. Okay, so we will consider the clockwise direction of the our moving. So let's say we are actually moving from the circuit, and let's say that E1 comes first, right? So we will say that E1 is a EMF source, and I have written here is fall of potential. Why is it so? Because we are moving from positive of side of the E1 to the negative side of the E1. That is, there may be there is a fall of potential from when we are moving from the E1. So what will be the sign? Negative sign is given to the E1, right? Next is E2. We will consider this resistors in afterwards, but first we will consider the EMF in the circuit. So let's say E2, that is this voltage source, that is this EMF, and there is a rise in the potential. Why is it so? It is we are moving in a clockwise direction, and it is increase from negative to positive. Eh, so voltage is increasing in this direction, so we will take it as positive of E2, right? Next, we will consider all resistors in the circuit, right? So R1, R2, R3 and R4. So where is R1? Here. So what is R1 is doing is we are moving from this direction and opposite to the current, right? Current is flowing in this direction, but we are moving in opposite direction of the current. So let's say we are moving from minus sign to plus sign, so there is a rise in potential. So R1 is from minus to positive, so we will take it as positive I1 R1. Why I1 R1? We know that V is equal to IR as our Ohm's law. So we will consider the current flowing through the resistor and the voltage across it. So Kirchhoff's voltage law is of algebraic sum of voltage, right? So we will consider voltage across the resistor R1. So it is positive sign given to the I1 R1. Next we will move to the R2. Where is R2? Here. R2 is a resistor in this line, and the current flowing through is I2. So what is the point here? We are moving from the positive to the negative of the R2, that is resistor. So when we are moving, there is a fall of potential. Okay, so it is in the direction of the current. Here in the R1 we are moving against the current, right? Here we are moving in the direction of the current, so there is a fall in the potential, right? Potential is V only. Okay, so fall in the potential, so we will write it as negative sign here, so negative of I2 R2. Okay, next is R3. We are moving in this direction, in the direction of the current, so that is from positive to negative in the of the R3, so we will consider as negative. Same like R3, we are going through R4, that is positive to negative, and we will find it as fall in the potential, and that is I4 into R4 with the negative sign, right? So we can write from this all the sign convention. By following all these sign convention, we can write the formula. What the theorem is saying, that algebraic sum of voltages, right? So what are the algebraic sum of voltages? That is minus E1 plus E2, will take it as a bracket. Okay, next plus I1 into R1 plus what is in the resistor 2, that is minus I2 into R2, then plus minus I3 and R3 with minus sign, then we'll take I4 into R4 with negative sign. Okay, and what laws is saying, this all summation is 0, so we can write it as minus E1 plus E2 plus I1 R1 minus I2 R2 minus I3 R3 minus I4 R4 is equal to 0. Okay, so finally we get our simple solution of the circuit. So these are we have learned the Kirchhoff's law. Thank you.